So today we're going to learn about the chain rule. Chain rule is going to seem kind of complicated, but once you guys get the hang of it, I think you guys should be able to do this pretty well. Basically, a chain rule is if f and g are both differentiable and f equals f of g is the composite function defined by f of x equals f of g of x, then f prime equals f prime g of x g prime of x. So what does that mean? That means basically if we ever have a composite function, right, then what we're going to do is we're going to differentiate the outside, keep the insides the same, and then multiply by the derivative of the insides. Okay, so that's what that looks like. You can pause the video and copy that down. And here's our example. Okay, so here's our function, square root of 4x cubed minus 5. So the outer function is the square root, the inner function is 4x cubed minus 5. So the first thing we're going to do is we're going to derive the outer function, which is the square root. And we're going to label our inside stuff as stuff. And the reason why I'm doing that is so that I don't accidentally derive this stuff. And then I'm going to derive the stuff afterwards. So once again, derive the outer, leave the inside the same, then derive the inside. So in this case, we have the square root of stuff. We're going to derive that square root, and then we're going to derive 4x cubed minus 5. Okay, so the derivative of the square root is 1/2, and then negative 1/2 as my exponent. We're keeping the stuff the same, I'm just leaving it as the word stuff. And then if I derive 4x cubed minus 5, I get 12x squared. Okay, now I'm going to leave my stuff inside. I'm going to put that back in there, which is 4x cubed minus 5. And I'm going to simplify both of these. So 1/2 times 12x squared is 6x squared. And then that's times 4x cubed minus 5 to the negative 1/2. I don't want any negative variable or exponents. So I'm going to get 6x squared over the square root of 4x cubed minus 5, or 4x cubed minus 5 to the 1/2 power. Okay, so take this time now to pause the video and copy down the instructions. This will make a lot more sense once we start doing this often, and so that you guys can see how it's done and get used to it. And it's actually pretty easy once you get the hang of it. Okay? Okay, so now let's look at our first example. So we have f of x is equal to the square root of x squared plus 1. So first thing I'm going to do is I'm going to derive my outer, d of dx of the square root, and I'm going to label my stuff as x squared plus 1. Okay, so we're going to derive the outer, and we're going to leave the inside as just stuff. And then we're going to derive our stuff, which in this case is x squared plus 1. Okay, so the outer, this is basically stuff to the 1/2 power. I'm going to move the 1/2 power to the front, and then I'm going to subtract 1. Oops, I can't spell stuff. I'm going to subtract 1 from the 1/2, which gives me negative 1/2. Okay, and now I'm going to derive my inside stuff. So the derivative of x squared is 2x, and the derivative of 1 is 0. Now that I'm done, I'm going to go ahead and insert my stuff back in here. So I get 1/2 of my x squared plus 1 to the negative 1/2 power times 2x. And I'm going to simplify that. So 1/2 times 2 is 1. So on top I get x, right? Because that's this times this. And then on the bottom I'm going to go ahead and write my x squared plus 1 to the 1/2 because I don't want any negative exponents. And there's my answer. Okay. Let's look at the next one. Now for this one right here, we have two different examples because they are two different problems. Here we have sine of x squared, where our stuff is squared, versus over here we actually have sine of x and that whole thing is squared. So our stuff in this case is sine of x. Our stuff in this case is x squared. Okay, so let's do this first one first. We're going to label our stuff as x squared. I'm going to derive my outer and then leave my stuff inside. And then I'm going to derive my inner, which is x squared. Okay, so the derivative of my outer, the derivative of sine is cosine. And then the derivative of, and I'm going to keep my stuff inside here, sorry. And then the derivative of my inner is going to be 2x. So now I just need to reinsert my stuff, x squared. And I actually like to put these things in front of my trig function just because it is less confusing and you're not going to confuse it with our angle in this case, which is x squared. So 2x cosine of x squared is our answer. So for the second one though, we have different stuff. In this case, and you may want to make note of this so that every single time you see sine squared of x, you know that it's sine of x squared, right? Or you can do sine of x times sine of x and just do a product rule if you wanted to. But in this case, our stuff, right, is equal to sine of x, right? So my outer is going to be the squared part. So I'm going to put stuff inside, and then I'm going to derive my stuff. In this case is sine of x. So to derive my outer, I'm going to put the 2 to the front, and then I'm going to subtract 1 from it, which is just to the first power, and I'm going to put my stuff back inside. Apparently, I don't know how to spell stuff. And then inside here, I'm going to go ahead and derive my stuff, which in this case is cosine of x. And now I'm going to put my stuff back in, and I get 2 sine of x cosine of x. And this is my answer. Okay, so make sure that you do note that these are two different things. They are not the same answer. In this case, our angle is squared, versus over here, it's saying multiply sine by itself twice. So you can use chain rule, or you could have used product rule. Okay. And let's look at this last one right here. So, once again, we have a chain rule because we have an outer function with an inner function on the inside. So I'm going to first, let's first define our stuff. Stuff is equal to x cubed minus 1. And so I have d of dx of my outer. And then I'm going to derive my inner. Okay, so my outer, I'm going to move 100 to the front, and then have my stuff be the same, and then this is 99, and then derive x cubed minus 1, so that's 3x squared. Okay, and now I'm going to put my stuff inside. So 100 times x cubed minus 1 to the 99th power times 30, times 3x squared. And then I'm going to go ahead and simplify. 3 times 100 is 300, x squared, x cubed minus 1 to the 99th power. If I wanted to, I could factor this, but I'm not going to. It's pretty compact the way that it is. Okay, so just to review once again, we're going to use this method, which is the chain rule, anytime we have an outer function, right, with an inner function. These are all for composites. Okay, and we're labeling our inner stuff as stuff just so that we don't accidentally derive this on the inside. We want to make sure that stays intact, and then we derive it over here afterwards. Okay, there are going to be times when you're going to have to do the derivative more than once for your stuff, and you're going to have multiple stuffs, but we'll go ahead and look at that next. Okay, let's look at our first example. Actually, probably the fourth example. For this one we have our stuff, and if you notice, our stuff happens to need a quotient rule in order to derive it, okay? So we're gonna set this up. Once again, our stuff is our inside, so let's just call that over here. Stuff is equal to t minus 2 over 2t minus 1. And if you know a different way to do this and you don't want to use stuff or the word stuff like I'm doing it, feel free to do that. Just make sure that you show all your work and that you get the answer correct, of course. So first thing I'm going to do is I'm going to derive my outer, and then I'm going to derive my inner. Okay, and I'm just going to take it in order so that I'm not deriving more than I can at the same time, and so I'm not forgetting anything. So in here, I'm going to have 9, and then I'm going to put my stuff, right? And then I'm going to subtract 1, and so I get 9 stuff to the 8th power. Over here, I have a chain rule, so I know I'm going to do 2t minus 1, then the derivative of t minus 2 minus t minus 2 derivative of my denominator, 2t minus 1, all over 2t minus 1 squared. Okay, this is already done. We now need to take care of our stuff. So I have 9 stuff to the 8th power times, in this case, the derivative of t minus 2 is 1, right? So I get 1 times 2t minus 1 minus, this stays the same, t minus 2, and the derivative of 2t minus 1 is 2 in this case, okay, over 2t minus 1 squared. Now, anytime, like we know already, that we have a numerator that has some multiplication to be done, we have to do that. We have to simplify that, okay? So I'm going to go ahead and put my stuff back inside here, since I'm done with the actual deriving of everything. And over here I have 2t minus 1 minus 2t plus 4, because I'm distributing this negative along with that too. All over 2t minus 1 squared, right? And then my final answer is going to be, let's see. Actually, let's go ahead and simplify this top part up here. This cancels out. Right, and then we just have a 3 on top. So I have 9t minus 2 over 2t minus 1 to the 8th power. On top over here, I'm going to have 3 over 2t minus 1 squared. And can I multiply the 9 times the 3? Yes, the answer is yes. So I get 27 over 2t minus 1 squared times t minus 2 over 2t minus 1. That's to the 8th power. And that's it. We don't need to multiply it out anymore because this is to the 8th power. That's a lot of multiplication. We don't need to do anything more than that. We can just leave this like this. Okay? Okay, let's look at our next example. And in this example, if you notice, we actually have double stuff, okay? So our overarching problem, though, is a product rule. So we're going to set this up as a product rule first, and then when we start deriving our separate components, and that's when we're going to throw in our chain rule. I'm going to go ahead and label my stuff, though, first. So I'm going to say stuff is equal to 2x plus 1. And you can label the second amount of stuff anything that you want. It doesn't actually matter as long as you know not to derive that until it's needed. I'm going to call it more stuff. And that's equal to x cubed minus x plus 1. And I'm labeling it just so that I don't get them mixed up later when I start to put them back inside. Okay? So like I said, the overarching problem is actually a product rule. So I'm gonna set it up as a product rule first. And so I'm gonna do 2x plus 1 to the 5th power d of dx of my x cubed minus x plus 1 to the 4th power plus x cubed minus x plus 1 to the 4th power d of dx of my 2x plus 1 to the 5th power. Okay? And so now I'm going to go ahead and derive. This stays the same, 2x plus 1 to the 5th power. And I know I'm going to derive my outer, right? And we're going to call that inside part stuff. And then I'm going to derive my stuff. These start to get pretty long sometimes. So x cubed minus x plus 1, right? And then I'm gonna do the other side. I have x cubed minus x plus 1 to the 4th power, and I'm gonna derive my outer, which in this case is more stuff. Oops, nope, this one is more stuff. Sorry about that. More stuff, and this one is my stuff, because my stuff is 2x plus 1. Sorry about that. And then I'm going to derive my actual stuff. Oops, sorry. d over dx of my 2x plus 1. Okay? So now I'm going to go through and start to derive. So in this case I get 2x plus 1 to the 5th power. That stays the same. Over here I'm going to do multiply that by 4, and then my more stuff stays the same. I'm going to subtract 1 from there, so that's 3. This is more stuff. And then I'm going to derive my inner parts over here. So I get 3x squared minus 1, keep those in parentheses, plus x cubed minus x plus 1 to the 4th power. And here I'm going to derive my outer. So that's 5, and then my exponent changes to a 4. This now stays the same as my stuff. And then I derive this portion right here, which is 2. That's it. So I'm going to throw my stuff back in, and then I'm going to simplify, okay? So I have 2x plus 1 to the 5th power. I'm going to put this 4 out front because it's a coefficient now. And my more stuff is x cubed minus x plus 1 to the 3rd power, and then times 3x squared minus 1. Over here I have 5 times 2, so that's 10. And I have x cubed minus x plus 1 to the 4th power. And then my stuff, I'm throwing that back in, so I have 2x plus 1 to the 4th power. But I'm not done. I need to simplify this, and I need to see if I can factor anything out. So in this case right here, this is one term. This right here is a second term. What do these two terms have in common? Well, so my greatest common factor is going to be, in this case, a 2. I have at least 4 2x plus 1s, right, in each of these. So 2x plus 1s to the 4th power. And I have at least 3 x cubed minus x plus 1s. So I'm going to factor that stuff out, and then I'm going to simplify what's on the inside, okay? I know these are really long and tedious, but can you imagine having to do the a plus h on these? That would take forever. So I'm going to put my GCF out front. And then on my inside, over here, I have a 2 left. And then I have a 2x plus 1 and a 3x squared minus 1. And over here I have a 5 left. And I have an x cubed minus x plus 1, and that's it. So this inside part I have to multiply because it's still I have that plus sign in between it, which means that this is a polynomial, so I have to simplify this whole polynomial. I don't need to multiply this part out. I do need to multiply the inside part. So excuse me while I move it up. So this stays the same. And then here, I need to multiply this out, okay? Let's hope I do it correctly. So we're gonna do 2x times 3x squared, which is, so let's do this. I'm gonna leave that 2 out there for now. 2x times 3x squared, which is 6x cubed, and then times -1, -2x, and then times 1, so 3x squared minus 1. Everybody following along? And here I just need to distribute this 5, so I have 5x cubed minus 5x plus 5. I still need to simplify some more. Like I said, this starts to get really long. 2x plus 1 to the 4th power, x cubed minus x plus 1 to the 3rd power. And then I have 12x cubed minus 4x plus 6x squared minus 2 plus 5x cubed minus 5x plus 5. And then I want to simplify. So here I have an x cubed and an x cubed. I only have 1x squared, and then I have my 4x and 5x, and then my constants. So I get 2 times 2x plus 1 to the 4th power, x cubed minus x plus 1 to the 3rd power, and then I have 17x cubed, right, plus 6x squared minus 9x plus 3. And now I am finally done. Okay. Okay, here's the last problem. And in this case, we have e to the sine of x. Anytime you have e to the x, that is just a normal problem that we don't have to do chain rule. Anytime this is more than just an x, if it's an x squared, a 2x, anything else, you have to chain rule it. That actually is the same thing for when you have trig functions. So if I have sine of x is what I normally have, anytime that x is something different, for example, if I have sine of 2x, or I have sine of x squared, or sine of cosine of x, right? Each one of these here means we have to do a chain rule. So anytime that your angle is something different than x, or in this case, our exponent is something different than x, you have to chain rule what you have. Okay, and that's gonna be the hardest part, is figuring out when you're gonna have to chain rule something. Okay? So, in order for us to chain rule, to do this, we're gonna derive the outer, actually let's label our stuff. So in this case, our stuff is sine of x, right? So we're gonna do the derivative d of dx of e to our stuff. And then we're gonna derive our stuff. So it's pretty simple, right? We don't have to do anything too complicated, but we do have to remember that anytime that is more than just an x, we have to do this. So in this case, the derivative of e to anything is e to anything. So this is equal to stuff, right? And then I have to derive my stuff. In this case, we have the derivative of sine is cosine of x. And now I can throw my stuff back in here, and I have e to the sine of x times cosine of x, or cosine of x e to the sine of x. Both of them are the same, and both of them are the answer. Okay? And I just want to give you one more thing to add to your derivative list. The derivative of a to the x power, right, is going to equal to a to the x ln of a. So put this in your little toolkit or whatever it is that you call your notes where you have all your derivatives listed, and put that down. Okay, so for example, if we had 2 to the x power, right? In this case, our a is equal to 2, so this is going to equal to 2 to the x ln of 2. And that's our answer. And we could plug that into a calculator if we wanted, or we can just leave it like that. Okay? So that's all the notes on chain rule. If you have any questions, make sure that you go talk to Mr. Bethel, or even Jensen could probably help, but Bethel I think is going to have more time because he's got mostly freshmen and hopefully they're not as needy on the stuff that they're learning at the moment as the stats kids over at Jensen's room. So you can always text me also if you need any help, and hopefully this made sense. Okay, we're done.